In man, long eyelashes, 10 millimeters or longer. And when we say in man, we just mean in humans. Is dominant, big L over short eyelashes, little l. Less than 10 millimeter long eyelashes come from little l. Ken and Carol are both heterozygous for this trait. And we are trying to determine what percentage of the offspring would have long eyelashes and what percentage of the offspring would have short eyelashes. Please go up to the very beginning up there and underline long eyelashes is dominant. Long eyelashes is dominant. We also need to figure out what percentage of the offspring would have short eyelashes. And we want to show our results in our Punnett square. So the P1 generation, the parents, what are their genotypes? It says that they are heterozygous, meaning that they should have big L, little l from one parent, big L, little l from the other parent. The possibility of gametes that we can get. One parent can give big L or little l. The other parent can give big L or little l. So let's do our cross for our F1 generation. Big L, little l, big L, little l. Big L comes down, little l comes down over here. Big L comes across, big L comes across, big L comes down, little l across, little l down, little l across. So we need to go back to answer our questions. What percentage of the offspring would have long eyelashes? So what are we looking for in order to determine whether the offspring would have long eyelashes? That area that we underlined may help us with that. Yes, sir. We're just looking for big L, right? Anytime we see big L, because big L is dominant, the allele for long eyelashes is dominant. Anytime we see that, the offspring is going to have long eyelashes. So we circle any of them that have a uppercase L in them. In this case, we have 3 of 4, or 75% of the offspring would have long eyelashes. And then the next question is, what percentage of the offspring would have short eyelashes? Well, if 75% are going to have long eyelashes, and we only have one box left, that tells us that 25% of the offspring have the possibility for short eyelashes. Let's look at number 5. You and your spouse have 3 children, all showing a normal thumb for flexing less than 90 degrees. What genotypes would your spouse have for your only granddaughter to show the physical trait for hitchhiker's thumb? Little b, little b. With hitchhiker's thumb, you can flex the thumb back 90 degrees. So this becomes a little bit trickier. In order for your grandchild to have hitchhiker's thumb, you have to have little b, little b. What does that tell us about the grandparents? What information can we gain with regard to the grandparents with what is supplied?
They're both carriers for hitchhiker's thumb.
They would have to be carriers, or at least one of them would have to be carriers. Okay? So their genotypes would have to be big B, little b, or b, little b. It doesn't tell us that whether the grandparents have hitchhiker's thumb. However, it does give us more information. It says all three of your children, have normal thumb for flexing, less than 90-degree angles. It wants us to show a cross between two heterozygous individuals for the trait. What percentage of the offspring would show a normal thumb movement? So let's do it. The parents all show normal thumb, meaning that the parents of your grandchild all probably need to be carriers, because in order for your grandchild to end up with hitchhiker's thumb, they would at least have to be carriers. They would have to both contain a little b. In this case, it's saying they're heterozygous. So let's put it in. We'll say both parents are heterozygous, just like it says. So there's our cross, big B, little b, and big B, little b. What alleles or what possibilities can one parent give? Big B or little b. What can the other parent give? The same, right? Big B or little b. So let's do our F1 generation. Big B, little b. Big B, little b. We're going to use our Punnett square to figure out what the F1 generation is going to look like. Big B comes down. Big B comes across. Little b comes down. Big B across, big B down, little b across, little b down, little b across. After showing a cross between two heterozygous individuals for the trait, what percent of the offspring would show a normal thumb movement? What percentage of these offspring would not have hitchhiker's thumb? Not 25%. 25% would have hitchhiker's thumb. 25% would have hitchhiker's thumb. We're looking for what percent would not have hitchhiker's thumb. 75% would not have hitchhiker's thumb. Any questions there?